Hey math fans, welcome to section 1.3.1. Let's get started. Example 1. A local convenience store owner spent $10 on 144 pencils to resell at the store. What is the equation for the store's profit if each pencil sells for 50 cents? Graph the equation using a table of values. So to start off this problem, what we're going to do is we're going to start with the $10 the convenience store owner spent. And if you think about it this way, that's not $10 he has to spend, that's $10 he's already spent. And so what I'm going to do is I'm going to write it as minus 10. He's actually $10 in the hole, so to speak. So he's down $10. He's missing $10 because he spent it on these 144 pencils. But he's going to sell the pencils for 50 cents each. So he's going to be making that back at 50 cents each. And then that's where we're going to actually put in the variable. We're going to put in that variable right there. So if he sells one pencil, he'll be making 50 cents, but then he's still down the $10. But eventually, when X becomes large enough, it will balance out the 10 and hopefully maybe get to 0, and we call that breaking even. So let's finish the rest of this. So Y is going to stand for the amount of money, okay, the store owner has, okay? And the X is going to stand for how many pencils. Now it says graph the equation using a table of values. I'm going to show you guys a shortcut later called slope-intercept form, where you use the slope and you use the intercept, and it makes it very easy to graph. But for today's lesson, I want you to make a table of values every single time. In fact, in the homework, that's the only way you can get around doing the problem, because you have to draw the line in between two exact points. So let's practice that. So I've labeled my table X and Y. And 0 is always a good starting point. 0 is always a good starting point. And if I plug 0 into X, I will get 0.5 times 0 minus 10. And guess what I'm going to get out? You guessed it, negative 10. This right here is going to be known as the y-intercept. Okay? The y-intercept always has the X value equal to 0. Now I had to redraw my graph because my graph didn't go down to negative 10, so I had to start all over, and that might happen to you. And so 0 comma negative 10 means that I'm going to be putting my first dot right here, down here at negative 10, over 0, down negative 10. Let's fill out some more points. Now, a lot of this is going to be guess and check, because I would say don't go up by 1, go up by 2 or 3, experiment, try plugging in all sorts of numbers, because we're trying to get to a certain point on the graph. And so I would say, why don't we try plugging in 5, or let's plug in 10 and see what we get. So when I plug in 5, I actually get negative 7.5, which is kind of tough to graph. And on your homework, that might be also a difficult number to work with. Yet when I plug in 10, I get an exact value of 5. 10 times 0.5, you get 5 minus 10. Oh, I'm sorry, it's negative 5. And that's an easier number to graph. So I am going to graph that. So I'm going to come over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And at negative 5, 1, 2, 3, 4, 5, 10, negative 5 is my other point. And so I know that my graph is going to be traveling up this way, and it's going to go through that point. But we really want to know when the store owner is going to break even, I think. And my best guess is probably, let's try 20. Because if 10 got us halfway there. Let's try 20. If I plug in 20, 20 times 0.5, well, that's 10, right? 10 minus 10 is 0. And then so all the way up here at 20 is where this thing is going to be intersecting the x-axis. So there's my line, and I'll just kind of color it in now. I'm not going to keep it dotted, but I would say lightly draw the line at first and then color it in using a ruler. But after he sells 20 pencils, that's when he's going to break even. Of course, this keeps going on until he sells 144 pencils, but we can continue this model. But there's a good way to start graphing, especially if you're going to be doing problems where you have to get kind of exact points, and I'll show you that with the last example. Let's move on to example 2. A taxi company in Kansas City charges $2.50 per ride plus $2 for every mile driven. Write and graph the equation that models the cost of the taxi ride. Use the slope and the y-intercept to draw the graph. Okay, so this one doesn't say make a table of values, but I want you to do it anyway. Okay? So no matter what, y is going to stand for the cost of the taxi ride. You should always do that. What does x stand for? What does y stand for? And then x is going to be the number of miles driven. Okay, so no matter what, it costs $2.50. I don't know how many people would hop into a taxi and be like, yes, excuse me, could you please take me 0 miles? And then the taxi driver says, that'll be $2.50. So, but that is a base cost. That's going to be a constant. So let's just write it over here. $2.50. It doesn't get a variable. It's just going to be a constant. And then $2 for every mile, we'll write the 2 there, and then the x there for the number of miles. Okay, so there's our variable for the number of miles. So if we drive 1 mile, 2 times 1 is 2, plus the $2.50, you'll be charged $4.50, and so on. So let's make a table of values, though, just to make sure our graph is going to be correct, and so it will help us with the homework. Again, I like to start with the y-intercept. So when x is equal to 0, what will the value of y be? Well, it will be $2.50. Now, in this case, it's going to be a little tough to graph. I'll just do my best here. Let's see, 1, 2, 2.5. It's going to be about right there. And when we fill in some more table values of 1, we get $4.50. So this is going to go up pretty quickly here. So $4.50 is here. And then 2 is going to be $6.50. So what is this? 5, 6, 50. And it should be making a straight line, okay, as best as you can. And as you can see, when you get to 3, it's probably around 850. This should be 3, 850. All right, and then it continues on depending on how many miles you've driven.